In this video, I'll teach you how to optimize your OpenClaw to save over 90% in API use. We'll go over caching, we'll go over model routing and selection, we'll go over context pruning, I'll show you how to run token audits so you can actually see how much money you are spending, and overall, by the end of this video, I guarantee that you will save more money on OpenClaw than you ever thought was imaginable. Now, I say that as someone who's now used billions of tokens. I have spent myself hundreds of dollars on OpenClaw, and I realized very quickly that this was not sustainable. So I went ahead and created a very detailed guide, what you're going to see here, on how to reduce the cost. I myself went from spending over $100 per day to now spending less than $5 per day, and recently helped one of my friends who is spending $200 per day now spend about $10 per day. This works. All you have to do is follow along. So with that said, let's get into the video. So first things first, I just want to give a little bit of credit here to Matt Ganzak. He's really been on top of the OpenClaw stuff, is a great guy to follow. And I saw his guide on how he saved 90% usage on his OpenClaw a few days ago. And I decided that I wanted to make my own version of it, enhance it, make it better, and just walk through it step by step. So massive shout out to him. I'll leave his video in the description, and just want to be clear that I'm by no means copying what he did, but I just got some inspiration and wanted to give credit where credit is due because he's been on top of the OpenClaw stuff for a long time. Now, with that said, what I have done is I have created a guide that explains exactly how to do everything that I'm going to show you in this video. So any of the prompts, any of the stuff that I mention or that I put in one of the files is all available here. And while you probably could just follow this guide and have everything done without the video, obviously it's easier to watch in video format because you have visuals. I can explain stuff to you. You get the idea. Now, you can download this guide for free by clicking the link in the description, and all I'm going to ask is that you give me your email so I can send it over to you, and then I can send you more OpenClaw stuff later in case you're interested. Okay, so that's the guide, and I will be referencing this in the video, again, available from the link in the description. Now, with that in mind, I quickly want to talk about setting up OpenClaw. Now, I assume some of you already have OpenClaw set up, some of you do not, and I want to just let you know that I have 2 previous videos on this channel that go much more in depth in terms of all of the setup and configuration steps, not related to the model optimization and saving money on API costs. So this video is purely focused on that. I will set up a new OpenClaw instance from scratch just so that I'm starting from scratch and I don't have anything that you guys don't have. But if you want a full, secure, hardening setup guide, I have one right here. I'm not going to repeat all of those steps. If you want to understand how to enable skills, voice mode, all of that, I have another guide right here. Again, I'm not going to repeat all of those steps. So what I'm going to do now is I'm going to set up a new OpenClaw instance. If you don't already have OpenClaw set up, you can totally follow along with what I'm going to do here, and it is completely fine. I'm just making you aware that there's more details in some of the other videos in terms of all of the other config, but of course, this is also very important. Now, with that in mind, I am going to recommend that you do set up OpenClaw on a virtual private server. This is just a general best practice. It gives you an isolated environment, and the method I'm going to show you in this video allows you to set up with literally a single click, so you can skip all of the configuration that would be required if you wanted to run this on, for example, your own local computer. Definitely don't run it on your own machine. Whatever you do, at least run it in some type of isolated environment, and just be aware that this can be insecure if you don't know what you're doing, so make sure that you set it up correctly. Now, with that in mind, for this video, I'm just going to make a new OpenClaw instance using Hostinger. This is a long-term partner of the channel. They are personally what I use for all of my OpenClaw bots already, and they have a KVM2 plan here, which is as low as $7 per month, actually even cheaper if you use my discount code. So what I'm going to do is just go ahead and press on select plan and walk you through the options if you do want to use Hostinger. Now, they have a one-click install option, which means you literally just go through this and it deploys OpenClaw for you automatically. It does that using Docker, which is also a secure way of doing this. Again, if you want the most secure kind of overkill method, I'll leave a video on screen that you can watch. Last overall message to you here, just because I really don't want you guys to get hacked, make sure however you run this, whether it's Hostinger or something else, you do it in an isolated environment where it doesn't have access to your main computer, doesn't have access to your primary accounts, and anything that got exploited, lost, exposed, whatever, wouldn't cause you a massive amount of pain. Okay, so with that said, if you do want to use Hostinger, if you're following along with me here, just select whatever plan you want. I'll go with 24 months. For the coupon code, you can then enter the Tech with Tim code. By the way, this does not work on the 1-month plan. It only works on 12 months or above, and that will give you an additional 10% off. I'm going to recommend that you uncheck this ready to use AI because you can just use your own keys. You don't need that. And then what you can do is choose a location. In my case, I'll go with Malaysia because that is closest to me here, and then go ahead and press on continue. Now, at some point during the setup process, you will see a screen that looks like this. Just make sure you include at least one of these 4 API keys. So in my case, I'll go with Anthropic, but you can go with anything that you want, and then just press on deploy. Okay, now while this is provisioning here, I am just going to recommend that on any of the platforms that you do get an API key from, you set a monthly spending limit and that you don't enable automatic recharge. We just want to make sure that if your API key were to get leaked for some reason, that someone couldn't absolutely rinse you and just have like a ton of money being charged to your account. So ensure that you have some kind of limit. In my case, I set $100 per month, and that you check this platform regularly, whatever it may be, to ensure that you're not spending a massive amount of money. Again, I'm going to show you a bunch of stuff in this video, so that shouldn't happen. But just for security, always lock down your API platforms and make sure that you have some kind of spending limit. Okay, so this is just being deployed right now. You can see it's spinning up OpenClaw. Once that is done, what we're going to do is just get into the gateway. We're then going to SSH into the OpenClaw machine, start doing some configuration, and I'm going to show you how we can view the files of the OpenClaw instance in a nice kind of UI or user interface, so that we can start modifying some of those and making the changes that will, well, reduce our cost. All right, so the project is deployed. Now, the first thing we'll do if we're using the Hostinger deployment is we'll just press on this OpenClaw button here from the dashboard. Now, by default, what Hostinger will do if you use the one-click install is it will actually install OpenClaw for you using Docker. This is a pretty secure way of installing it, but just be aware of that because it does change the way that you interface with the OpenClaw command, which I'll show you in a second. So you see it's opened up this page, right? It's given us access to this kind of URL. And what we can do is copy the gateway token and then just paste the gateway token inside of here and then log in. If you didn't get that, you can copy the gateway token. There's a button right here, press OpenClaw, sign in. It should bring you to the gateway. And now you can communicate with your OpenClaw bot by typing something like, hey. Now, once you verify that this is working and you've connected to the gateway, what we're going to do is open up a terminal or a command prompt, and we're going to SSH into the remote machine so that we can start configuring it. Now, I'm going to assume that you probably know how to do this if you've already set up OpenClaw. If you haven't, all this is going to do is essentially log in to this remote computer and allow you to execute commands on it. So what we're going to need is access to this command right here from the Hostinger dashboard in overview, where it says SSH root at and then the IP address of our server. If you're hosting this somewhere else, then you're going to need to know the IP address of your server, and you're going to have to know your user, which is usually root unless you've changed it. Now, because we're using Hostinger and it doesn't give us the root password by default, we're going to press this change button. We're going to generate a random root password. We're not going to expose that to anyone. We're going to copy it and we're going to confirm. So just change the root password to something that you can at least remember, or write it down somewhere in a secure environment, and just make sure you know the root password and you know the IP address of your server. Okay, then what we're going to do is open up a terminal. We're going to go into the terminal and we're going to copy the first command that we had. So SSH root at IP address of the server. Again, this is securely logging into the server so we can run commands on it. If you've hosted this somewhere else, you need the IP address and you need the user. Again, usually it is root. If the user is something else, you need the user and you need that user's password. If it's root, you need root and then you need the root's password. You can usually reset that from any hosting providers like UI, okay? So we're gonna go ahead and press on enter. From here, we're just gonna type yes and hit enter. And then what we're going to do is paste in the root password. Now to paste it, you can hit Control V on your keyboard, or you can right click on the mouse, depending if you're on Mac or if you're on Windows. You will not see anything appear here. That is completely normal, and just go ahead and press on enter. You also can type it in, obviously, but just be aware that you won't see anything. So just type it or paste it and then hit enter once it's correct. Okay. So from here, we're now inside of the server, but because Hostinger runs OpenClaw using Docker, if we want to access OpenClaw and start doing any configuration using the OpenClaw commands, we need to actually execute the Docker container. This is not complicated, but it just requires a few more steps, so bear with me. Now, if you're not using Docker, you should just be able to directly run the OpenClaw command here. So OpenClaw like this, but you'll notice that when I do that, nothing happens because the OpenClaw command is only available inside of what's known as a Docker container. A Docker container is just an isolated kind of environment that's running on the virtual private server, and it makes it so we can really easily restart the environment or shut it down, or create a new one if we need to, as opposed to installing everything directly on the server and not inside of this environment. Again, I'm just giving you some options because I don't know how your OpenClaw is set up. So from here, on the hosting or VPS, we're going to type docker ps. Now, docker ps is going to show us the different containers that are running. You'll notice two here. The one that we're looking for is the one that's labeled OpenClaw. Now, what we want to find is the ID of this container, which should be on the far left side like this. So we have 377, FF6, whatever. We're just going to copy that by highlighting it and pressing Control C. We're then going to type docker exec -it. We're then going to paste the container ID, which is the one that we just found from above, and we're going to type /bin/bash, okay? Now what this is going to do is it's going to bring us inside of the Docker container so we can start executing commands in there. Again, you're going to type this exact thing, docker exec -it. This is going to be whatever your container ID is, which will be different, and then /bin/bash, and go ahead and press enter. Now, what you should notice is that you get this ID changing here at the @ so it should change from SRV to something like this, and that is how you know, that you're good. Now, if you want to clear the terminal, you can type clear just so it brings you up to the top of the screen. Now, from here, if we type the OpenClaw command, we should be able to access OpenClaw. So let's wait for a second. It should start running, and this will allow us now to run the commands that we need in order to make some of the configurations and changes. Okay, so now that we're inside of the server, you understand how you can run the OpenClaw command and change something from here. What we need to find is the openclaw.json file, which is a file that we're going to start modifying in order to apply some of the model optimization changes we're going to make. Now, you can do this directly from inside of the terminal. And the way that you'll do this is by using the nano command, which is a built-in text editor. If I type nano, you'll see it open something like this. However, this is really not efficient and not going to be very easy for a lot of you to use. So I'm going to show you an additional method that allows you to view all of the files that are on your server if you're using a virtual private server, so you can modify them without having to use the terminal. Now, we still will need the terminal later, so we'll leave it open. But what we're going to do now is we're going to open a tool called Visual Studio Code. This is free. You can download it. It is extremely popular. Just search Visual Studio Code online. And I'm going to show you a way to remote access your server's file system. Again, this will make it a lot easier. And if you don't already know this, you're welcome, because this will save you a massive amount of time. So what we're going to do is open up Visual Studio Code. You'll see I was already connected to a session previously. And what I'm going to do is just go File here and New Window. You don't need to do this just because I already had something open. Okay, so from Visual Studio Code, don't worry if yours doesn't look exactly like this. It'll probably be a different color. What you're going to do is you're going to look for this kind of puzzle piece icon on the left side, and you're going to search for the SSH extension, which for some reason is taking a long time. And yes, this is what we're looking for, remote SSH from Microsoft. Okay, look for the one with the official check mark, and we're going to install this. So I already have it installed, but just find the extension again, puzzle piece, SSH, install. Now, once that is installed, you're going to hit the following shortcut on your keyboard, Control, Shift, and then P. Okay, now you also can press this button down here in the bottom left, which is open a remote window. Now, if you hit Control Shift P or Command Shift P, this is going to open up the command palette for you, which looks something like this. And you can type remote, and then you should see a bunch of options here. The one that we're going to look for is connect to host. So go remote-SSH, connect to host, just press it. Again, you can also press the button here in the bottom left-hand corner. So we're going to press that button. Now from here, you likely won't see anything. You'll just see add new SSH host. So you're going to press that, and we're going to type or copy what we used previously in our terminal. So SSH root at, and then the IP address of your server. Again, to find that, if you're using Hostinger, you would just go right here and copy it. If you use another provider, well, you have to find this SSH command. Okay, so we're going to go ahead and press on enter, where when it asks us to save this, just choose whatever the first option is, and then it should, save the config. Now that it is saved, same thing, Control Shift P or Command Shift P, open up the command palette, and we're going to type, again, connect to host. When we do it, this time we're going to select the IP address of the server that we just added. So I believe it is this one, and then it should open up a new window for us. Now in this new window, let me zoom in, we're going to select Linux. Okay, and we're going to copy the root password and paste it when it asks for the password. So it's asking for the password, we're going to paste it in and hit enter. Now what that is going to do is going to take a second, but it's going to open a remote view of our server that allows us to directly download, upload, modify files right from this user interface without having to use the terminal to make these changes. Okay, so you'll know that you're connected when you see this at the bottom left of your screen where it says editing on SSH. What we're going to do then is look for the Explorer, which is kind of like this file looking menu. You also could go File and then press Open Folder. So we're going to go Open Folder. When we do that, it's going to give us a prompt here in terms of selecting the folder. Now the folder that we want to select is going to be slash, and then it should be Docker. So we're looking for slash Docker. Then we're going to have slash, and we're going to select the OpenClaw folder. Okay, and then we're gonna go slash data like that, and we should see a .openclaw folder, which is the one that we want to open, and we'll go ahead and select it. Now, if you're not using Hostinger and Docker, then you're gonna have to find the location of this .openclaw folder. The normal locations for this will be inside of your users directory. So if you're root, it will likely be inside of just the root folder. If it's not inside of there, then it would be inside of slash home slash and then whatever your username is. So you can see like there's one called Ubuntu, but it could be in another location. Again, I don't know what location it's going to be in because I am not working with your, what do you call it? OpenClaw instance. So I don't know, but I just know here that it's going to be in this directory slash Docker slash OpenClaw slash data, then OpenClaw, and then go ahead and press on enter or open or whatever, trust and continue. And you should see all of the files pop up here on the left-hand side. Okay, so at this point, you should now see all of your files from that folder, and we're looking again for this openclaw.json file. Now, inside of this openclaw.json file, what we're gonna do is we're gonna start changing a bunch of settings so that we get this model kind of optimization I was talking about. Now, the first optimization that we're gonna make is model routing. Now, the idea is that you don't just wanna set one default kind of model and just have OpenClaw use that all the time. A lot of people are using Opus 4.6 for literally every single operation on their OpenClaw, which is costing them like 20 times more than they need to be spending. There are different models, even just within the Claude ecosystem, where we have Opus, Sonnet, we have Haiku, right? Sonnet, sorry, and then Haiku. You can use all of these and they can accomplish the same task. And in fact, sometimes even these cheaper models can just do it better because they're so much faster and they don't run into any rate limits. So what we want to do here is we want to change some of the model configurations so that we're using the correct models and we're routing between them accurately. Now, in order to route between them, we need to have different models that we can select. Now, what I'm going to suggest is that you add as many models here as you're comfortable adding, as long as you understand which ones you're adding, right, and which ones you want to use. So I would suggest having at least 2 different providers for the LLM models that you want to use. I'm going to show you exactly what I mean in 1 second, but right now we just have Claude, right, because I've just added the Anthropic API key. So what I'm going to do is I'm going to add an OpenAI API key, and I'm going to add a GPT model as well. So ideally, you want to have 2 providers. The reason why you want to have at least 2 providers is because if one of your providers gets rate limited, you want to be able to switch over to another provider so that you can start using that. So for example, if we're using Claude and all of a sudden we hit a rate limit, we don't want to wait 2, 3, 4, 5, 10 minutes before we can continue. We can just instruct the model or instruct the agent to switch over to now use the GPT model instead. Even if it's not quite as good, it can finish the task with GPT, and then when the rate limit is done, it can switch back over to use something like Opus or Sonnet. So what I'm going to do is just reference my guide here, because this kind of explains how to do it. So let's go to model routing. And as we scroll down here, okay, this is the setting that we're at. So we're editing this openclaw.json file. Now, what we need to do is we need to start by adding the API keys for the model providers that we want to use. Now, we've already added Anthropic, so we don't need to use that. But what we can do to add the API keys is we can add this env section at the top of our openclaw.json file that indicates the API keys for the other providers. So what you can do is just copy this section directly from the guide. So I'm just going to copy it here. You also could just type it in and just paste it at the very top of your JSON file inside of this first brace. Now, you have to be a little bit careful here because JSON is very sensitive to syntax. And you'll notice that JSON stands for JavaScript Object Notation, has braces. It then has these text fields that are surrounded in double quotation marks with colons. These are called keys. And then another set of braces or a set of string, right? And then another set of keys and then potentially values. Now, one thing to note is that all of these keys and values are separated by commas except for the one at the very end. So you'll see like comma, 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 but no comma right here. Make sure you don't accidentally add a comma here, because if you do that, it's going to yell at you and it's going to give you an invalid configuration. So if you get some error message saying like invalid openclaw.json, you just made a mistake in the JSON. And what I would suggest you do is just copy all of it, give it over to ChatGPT or something and say, hey, fix my JSON for me, and then it will fix it. Now you should remove the keys before you do that, but you get the idea. Okay, so you notice here that I have 4 sets of API keys. Now I'm just going to include the OpenAI API key, so I'm going to remove these other ones that I'm not going to use, but I was just putting those there as an example. So what we're going to do now is we're going to find an OpenAI API key and we're going to paste it here. The more models you put, the better, but at default, just have 2 providers. So I'm going to remove this. Now I'm going to go and I'm going to get an OpenAI API key. So I'm just going to say OpenAI API key, right? I'm going to go over to this page and I'm going to generate a new key. Okay, so I put the key inside of here. Obviously, I'll delete it after the video. And again, if you want other model providers, you put them here. Now, if you already included a key, like you already did Anthropic before, you already did OpenAI before, you don't need to replicate it here. Claudebot or OpenClaw or whatever is going to pull these keys from different locations. It will pull it from what's called your environment variables, which in our case is configured by Hostinger, or it will pull that from this env section inside of the openclaw.json. So don't worry about replicating a key if you already had it. This is just when you're adding a new provider. So now that we've added this new provider, let's go back to the guide quickly. What we can do is we can include some more models that we want to use. So if we go to my guide, you'll see that I have a new JSON file here. So what you'll see in this guide is I just have a short list of providers that you can just directly copy into your configuration. Now you're going to want to change the GPT-4o mini and 4o. This was just AI generated to the newest models like GPT 5.1, GPT 5 mini, which I'll change in a second. But based on the providers that you're using, now you find the list of the models that you want to use, right? And you add them into the config. So what I'm going to do just for demo purposes, I'm going to copy this whole model section here, okay? Or actually, I'm going to copy this whole defaults section just so we can copy all of it. I'm going to go to VSCode. I'm going to go to my defaults and I'm going to replace the defaults. Now make sure that you match up the braces so that I'm replacing this whole default section, right? And you can kind of see the line lining it up here. And I'm going to paste this and then I'm going to save, okay? Now to save, so let's just tab that in. You can hit Control S on your keyboard, or you can go up if you have this unexpanded and go File and then Save. Okay. Now, what you'll notice, right, is that we have a bunch of models here. So we have the Anthropic models we had before, and we have what's called an alias. Now, the alias is just a shorthand that we can call it so that OpenClaw understands, what the name of the model is. And you'll see that we have the 3 Claude models that we had before. So we had Opus 4.6, Claude Sonnet 4.5. I think now they have 4.6, so you could change this to like 4.6 or Haiku 4.6, right? You got to check what the recent model is, and then you can set your primary model. This is the default model that you use by default, to, in my case, Claude Haiku 4.5. The reason why I'm using this is the cheapest model, and we'll start by having the cheapest model and then tell the cheapest model to select a more expensive model if it needs that for the given task, which you'll have a look at in a second. So the point is we're adding various models. Now, in terms of these models, we want to remove any of the ones where we don't have an API key. So I don't have an API key for Gemini or DeepSeek, so I'm going to remove those, right? But I do have them for OpenAI, so I'm just going to adjust these quickly. So we're going to have GPT 5 mini, and then GPT 5.1, I believe, is the current one that we can use. So just adjust those so that we have the correct name. Now, if there's any issues with this JSON, again, you'll know when you run OpenClaw in a second, which I'll show you. Okay, so at least now we've selected or we've enabled a few other models. Now, in order for us to actually save these changes, because we're using Docker, we're just going to go back to our terminal. We're going to make sure we've exited out of the Docker container, which you can do by typing the exit command. So let's say we were back inside the Docker container. So we had this Docker exec command. You'll notice we're inside of it, right? Because of this ID. To get out of it, you just type exit, and now it brings you back to the root OS. Now from here, what we're going to type is Docker restart, and then we're just going to restart this container. So we're going to copy and paste this, okay? Now, when we paste the container ID, what this is going to do is restart the OpenClaw gateway for us automatically and apply any of the changes that we've made here in this file. So sometimes you'll make changes here, but they won't actually be applied. If they're not being applied, then what you need to do is you need to restart the gateway, which again, I just did from here. Otherwise, restarting the gateway is, you can run the OpenClaw command, like OpenClaw gateway restart. However, you don't want to do that if this is running through a Docker container for some various reasons that we don't need to get into. The way that you restart it with Docker is doing docker restart container ID. Again, the container ID you get from running docker ps like this. If you're running OpenClaw in a different way, then you can just run the Docker command I showed, or sorry, the OpenClaw command. So again, you can run OpenClaw and then gateway, okay, restart like I mentioned, and it will restart it for you. You can also just tell OpenClaw to restart the gateway. Okay, so now that that is applied, what we're going to do is we're going to go to the OpenClaw gateway. So let's go here, and we're going to say, what model are you using? And we're just going to test and see if it's using the correct model. Okay, so you can see we have the correct model here. Then I'm going to say, what models do you have access to? And let's enter it and see what we get. And you can see that it shows us now the 5 models. So just test that and make sure that it has access to these various models. So sorry, quick pause. I did realize they do actually have Claude Sonnet 4.6, so I just added 4.6. We also still have 4.5. We can remove that if we want. And then we have Haiku 4.5, but they don't have Haiku 4.6. So keep Haiku 4.5 as the default, right? Because we want the cheapest one, but then add 4.6 because obviously it's better than 4.5. Okay, so anyways, what I did is I was just messing around with some stuff in the chat, and I just wanted to show you that now that we have these models available, you can actually type /model, and then you can switch to a particular model if you want, or you can just tell the agent to switch. So say, switch to use the Opus 4.6 model, right? You can just tell it to do that, and then it can automatically switch to a different model. And this is the feature that we're going to leverage here now to handle model routing. So now that we have this, what we want to do is we want our OpenClaw to automatically select the best model based on the task that it's given. 90% of tasks you can run using this Haiku 4.5 model. It's still pretty good, it's very fast, it's very cheap, and if you need advanced reasoning, you can use Opus, and if you need something kind of in the middle, you can use Sonnet, which is significantly cheaper than Opus. So what we're going to do is we're going to go to our workspace here, and we're going to open up this sol.md file. Now, inside of this sol.md file, I mean, you can change this to anything that you want. What we're going to do is we're going to put in some model routing code, which is effectively a prompt telling this, okay, what model should you use based on what we're asking you to do. Now, you can find the exact prompt that I am going to use here if you just scroll through to step 4, adding routing rules to sol.md. Now, this is the prompt that I'm going to copy, so I'm just going to copy it in, and then I will read it to you, but you can change it to anything that you want. Generally speaking, it's going to be very similar, to this. Okay, so actually you are going to have to change it based on what we have here. So it says model routing rules, read before every task. Default, always start with Haiku, Claude Haiku 4.5. Switch to Sonnet. I'm going to change this to 4.6 because now we have access to that. Only when the task requires designing, reviewing, security, a major decision. If Anthropic is unavailable, okay, or rate limited, for example, then you can switch to these models in order. I'm going to remove the 2 we don't have, and I'm going to change this to GPT-5 Mini. Okay, so this is kind of the equivalent to Haiku. For complex tasks that need Sonnet level capability, switch to GPT 5.1, right? And then we put that like that, okay? Never switch models mid-task unless you hit a rate limit. Never use a premium model for writing, reading files, or simple questions, status updates, formatting, etc. And then if we wanted to add the Opus one, we can do another one, and we can say switch to Opus, right? Claude Opus 4.6, only when the task requires advanced reasoning that Sonnet is not doing successfully, right? So you can add whatever you want here for the rules, but the point is that we're adding routing now to this sol.md. So any time that we're asking for a particular task, it's going to be reading this and then switching the model as needed. Okay, so now that we have that, what we can do is we can just test, and we can say, based on your routing rules, what models should you be using in what situation? Right? And then we're going to go ahead and press enter. Now, it might not have it updated right away if we've changed the sol.md, but let's see, because we might need to restart the gateway. But it should now tell us, assuming it's reading the correct sol, what models it should be using. Okay, yeah, so it looks like I got to just restart the gateway before this is going to apply. So let me just go docker restart. And then when we restart, if we chat with it again, it should now have the sol.md updated, and we should be able to, get a correct answer. Okay, perfect. So the gateway restart worked, and you can see it found it in sol.md. And as default, Sonnet 4.6, Opus 4.6, and then the various fallbacks. Again, the fallbacks are important for if we hit a rate limit. Okay, cool. So we now have these rules applied, and already this is going to give us significantly better performance, but it's just scratching the surface of what we really need to do to configure this further. So to configure this even further, the next thing that we're going to add here is session initialization. Now, by default, OpenClaw is going to load a full conversation history of every message that you've sent, I believe, in the past 2 days into context anytime you create a new session. Now, this is extremely wasteful and also loads a bunch of other files that you don't need. So what we can do is we can tell it to only load the absolute necessities before, when a new session begins, so that we don't have all of this stuff bloating up our context, which is costing additional money. Now, the reason for this is that what ends up costing you money when you are using these models is the number of tokens that you're sending and the number of tokens that you're receiving. And think of token like a word. So if we load, the past 2 days of session history and you were chatting a ton, that could be, tens of thousands of tokens that are just being added wastefully to every single request that's sent to our API provider. So it's not really about the number of requests that we send, it's about the size of the requests that we send, and we want to reduce that size, and that's effectively what this is going to do. So there's another prompt effectively that I have here, which is session initialization. You, again, can change these rules to be whatever you want, but what I'm going to do is just copy this and then put this below what we had before in our sol.md. So same thing in sol.md, we're just going to paste this, session initialization, load limits. It says at the start of every session, load only sol.md, user.md, and then today's memory file if it exists. Do not automatically load the full conversation history, memory.md, session or logs from previous days, tool outputs from past sessions, and when the user asks about past context, run memory search. If found, run memory get, return only the relevant snippet, do not load the whole file. And at the end of every session, write a summary to memory, keep it under 500 words, and the format is bullet point only. So I'm not going to go through all the files, but there's this file memory.md, which will slowly fill up with long-term memory that the bot keeps. Then you will have, we don't have it right now because it hasn't written anything yet, but you'll have like daily memory logs. The point is we only want to load what's necessary, and we'll search through the memory to see if there's something that's necessary before we load it. And this is an effective search that is, how can I explain this? It's just going to search the memory rather than loading all of it into an LLM. It's going to search it using standard searching in computer science and coding, which doesn't cost you any money. Then if it finds something relevant, only then will it load that. So anyways, what we're going to do now again is just save sol.md, and then same thing, restart the gateway from the terminal or in any way that you want, and we should be good to go here. We now have session initialization done. Now, I can't really prove to you that this is going to work, but you should see that it reduces the context size. And now we're going to move on to the next feature, which is to set up a local heartbeat with Ollama. So a heartbeat is something that allows OpenClaw to automatically run at a set time increment. So every 30 minutes, every 60 minutes, every 2 hours, whatever. Most people have it set up to run anywhere from 30 to 60 minutes. Now, what the heartbeat is doing is effectively pinging the current tasks that are happening inside of OpenClaw and just kind of telling them to continue. It's a very, very basic task that does not require any level of intelligence to complete. And by default, if we use an LLM provider, so something like Anthropic or OpenAI, and we're sending a request every 30 minutes, we're just wasting money on these heartbeats because they're not really doing anything useful, but they're just checking, is there anything that needs to continue? Okay, continue, right? That's what a heartbeat is kind of doing. So you can read this, heartbeat is a scheduled check-in that OpenClaw sends to an AI model on a timer. By default, this would use your paid API credits. This step routes those check-ins to Ollama, a free AI that runs locally on your server that never costs you anything. So what we're going to do is we're going to install Ollama. This allows you to run LLMs locally on your own computer, and we are going to run a very lightweight, very easy to run model, Llama 3.2, on the computer that we can kind of delegate these heartbeat tasks to. Now, a lot of you might be saying at this point, okay, well, if we're going to run a local model, then what's the whole point of this? Why don't I just use a local model the whole time? The issue is that these local models that are capable of running on small VPSs or even my computer, huge computer that I have, are very limiting. In order to run these frontier models, which are the best, which are the ones you want running all of the time, you require a massive amount of hardware that costs, tens of thousands of dollars. So we can't run Claude Opus 4.6 on our own computer on a virtual private server unless you know more than me and you're not watching this video, right? So Ollama is just used for these really light, easy tasks that we don't really need intelligence for. We just need like a quick checkup, and then everything else we still go to the LLM provider for because it provides the intelligence that we value that we're willing to pay for, right? So anyways, what we're going to do is just follow these steps. So we're going to go into our server. What we can do is we can get out of the Docker container like we are, and we can run this command. This command is going to install Ollama for us. So curl fssl, right? And then running Ollama, wait for that to finish. And then the next thing that we're going to do is just make sure Ollama is installed. We're then going to start the Ollama service. I'm going to fix this because it's a little bit messed up in the formatting. We're going to pull the Ollama model. We're just going to test it to make sure that it's working. And then we can configure the heartbeat in our OpenClaw.json. You can see the code snippet right here to use Ollama every 1 hour or every 30 minutes or whatever, etc. Okay, so that's how that's going to work. And let's wait for this to finish installing. Looks like it was. Now you'll see that if you don't have a GPU, it says it's going to run in CPU only mode. That's fine. So we'll just run in CPU only mode. What we're going to do now, let me just look at my guide, is make sure Ollama is running. So we're just going to type Ollama. Okay, now if Ollama gives you any output, that is good. That means it is running properly. You can press escape to quit out of that. And then, like I said, we're just going to start the Ollama service and make sure that it's running. So we're going to copy this first command. So systemctl start Ollama. Okay, that's going to run Ollama for us. We're then going to type system enable. So systemctl, sorry. Okay, ctl enable, and then same thing, Ollama. Okay, perfect. And then if you want to check the status of it, you can run this command right here. However, you don't need to. Okay, cool. Then we're going to pull the model. So let's just separate this over here so it's a little bit easier to see. We're going to say Ollama, pull, llama, and then this is going to be 3.2:3 billion. 3 billion, by the way, stands for the number of parameters. You can install one that is much larger than this with like 70 billion parameters, but you just won't be able to run that on CPU, or you can, but it's going to take like forever to run. So there's no point. So we're just going to pull this model here, which I think is like 2 gigabytes, which again is capable of running on CPU. Okay, we're now going to copy in the next command, which is Ollama run llama 3.2 billion, and then we just put some quoted text like respond with only the word okay. We're going to hit enter, and then we should see that it runs the local model, and ideally we're going to get the text okay. Just give this a second to run. It says okay, and we can see that the model is working. So you can now ask it anything that you want, but you'll notice that it's going to be kind of stupid if you ask it something like really complex, like let's say, what is the capital of Canada? And like, I'm not even sure it's going to get that correct. Okay, it did get that correct. So actually that's surprising, but some things it will give you really stupid answers for, but again, that's fine just because we're using it for the local heartbeat. Okay, so now that Ollama is installed on the server, what we need to do is go back to our OpenClaw.json, and we need to effectively just copy this heartbeat snippet that I have in the guide here and put it inside of the default section of our agents. So if we go back to OpenClaw.json, I'll show you, we have agents, right? And then we have defaults, okay? Now, inside of defaults, make sure it's inside of defaults, otherwise it will mess up. So you can find kind of at the bottom here, we're gonna put a comma, and we're gonna put the new section, which is our heartbeat, okay? So I'm just tabbing this in so it's nicely formatted. And you can see we now have the heartbeat section, again, inside of the default section. So it comes right after the models that we have listed. We've said we're gonna use this model, which is the local model that we have access to. Just put it session main, target Slack. This is like the channel that you would want it to reply in. So just leave that. And then for the prompt, briefly check any blockers, pending tasks, or reminders. You can change the heartbeat prompt to be anything that you want. And you can also just put it directly inside of this heartbeat.md file. Okay, so anyways, that's now gonna run the heartbeat locally. So every 1 hour, it will trigger Ollama, and this is completely free and now will not cost you anything. Whereas before, if you had the heartbeat enabled, it would use a default model, load all of the context stuff, and cost you a bunch of money. So what we're gonna do is, again, just restart the gateway. So let's go back to our restart command, make sure that that is running. And now we're gonna move on to the next step, which is really where we're gonna get a lot of the cost savings. All right, so next step is to quickly add some spending limits and then to enable the prompt caching, which again is one of the major things. So I have another prompt here, which is related to spending limits. This is something that we can just place inside of the sol.md to instruct the model how it should deal with effectively what happens if we go over a certain amount of money, if we hit a rate limit, etc. So you can read this, but I'm just gonna copy it from the guide. And I'm gonna go here to VSCode. I'm gonna go to sol.md, and just after the other sections here. I'm going to paste this in. Now let's read it. Rate limits and budget rules. API call pacing. Minimum 5 seconds between consecutive API calls to make sure we don't get rate limited too quickly. Minimum 10 seconds between web research requests. After 5 web searches in a row, pause for 2 full minutes. Task batching, group similar tasks together. Daily spend target, you can change this to whatever you want, $10, $20, whatever. But notice it says at $3.75. Notify the user before continuing at $5, whatever. Monthly spend target, $150, right? Same thing. And then if you hit a rate limit, switch to the next available model in the fallback list. Note which model you switch to. Retry the same task on the new model. Tell the user what happened at the end of the session. Okay, so that if we hit a rate limit, which is very common, it knows now how to deal with it and it will switch to the other model. Okay, cool. So we're going to get out of that. And now we're going to move to the next section, which is to enable prompt caching. Now I'm just going to read this explanation, but prompt caching lets the AI provider reuse your system prompt, so sol user.md, across messages in a session. So instead of processing those files from scratch on every single message, the provider stores them after the first message and reads them from the cache on every message after, at roughly 90% lower cost for the cached portion. So what this means is that there's a huge amount of context, right, that's being read in from OpenClaw that's being sent to the LLM every single time. The sol.md always being sent, right? User.md always being sent. All of these memory files always being sent. If we enable caching, then as soon as we send it one time, the next time we read it, we effectively save, 10 times the amount that we normally would have. So if the first run costs 10 cents, the next run only costs 1 cent because it's cached. So that's roughly the math. But by implementing caching, you don't have to do any changes, no performance differences occur, and you just immediately save a massive amount of money. So the way that we enable caching here is we add this params parameter or value inside of the model configuration in our OpenClaw.json. Now, it's only worth doing this for the models that are larger, so ones like 4.6 and Sonnet 4.5 or Sonnet 4.6. There's no need to do it on something like Haiku because it's already so cheap. So you can also change the cache, so you can go short or long. So if you go short, it means the cache is held for approximately 5 minutes of inactivity. So if you stop using the model for 5 minutes, it will clear the cache. Whereas if you use long, it will hold it for 1 hour, which is much better. So for these larger models, you can go with long, right? And then for the smaller models, you can go with short. So what I'm going to do is just show you how we would add this, but it's very easy. And again, as soon as you add this, you're going to see literally how much money you save just by having the cache. And we can actually look at how much that costs in just a minute. So we're going to go now back to VSCode. We're going to go to OpenClaw.json. We're going to find the models we want to cache. So Opus is one. Notice I add the comma here, and then I paste this in, and I have cache retention long. For 4.6, I'm going to go cache retention and then short. Okay, and for 4.5, same thing. We're going to go here and just make this short. We're then going to save. Okay, so let's save all of that, and then go back and restart the gateway. And there we go. We literally just added prompt caching. Now, just to quickly show you this here, it does cost you some money to write to the cache, as you can see here. However, when you read from the cache, you save a massive amount of money on the expenses. But the thing is, if we look at something like Claude Haiku 4.5, it costs us so much to write to the cache, but then it doesn't give us that much of a benefit from $1 to 10 cents. So what we did with Haiku is we disabled that, but with something like Opus and Sonnet 4.6, Sonnet 4.5, you can see that we do value still writing to the cache. So you can have a look at these and you can see the other models too, how those work. But generally speaking, very cool, right? And just works well and saves us a bunch of money. So now that we have that, I'm just going to go right into the next configuration changes here. What we're going to do is we're going to add context pruning. Now, what context pruning will do is as the session grows longer, the old tool outputs and past messages, they generally accumulate and they get sent with every new message, even when they're no longer relevant. So what we're going to do is we're going to prune the stale content after the cache TTL stands for time to live window so that it doesn't bloat our costs. So effectively what this means is like after, in this case, 55 minutes, all of the old stuff that we're no longer using, we're going to prune that so we're not including it in the API requests going forward or LLM requests going forward, so we save some money. Now, the way that we do that is we just add this context pruning section inside of the default section in our VSCode config. So we just go find defaults, right? And then right below models, doesn't matter where we put it. We can just paste it inside of here, just as a new key, context pruning. And now if we save this, you can see we are good to go. And again, we just restart the gateway, and now context pruning will be enabled. And again, it will start saving us some money. So let's now go back and we can just move to the next thing. So I'm not going to do this right now, but if you want to monitor your cache performance after adding that, you can add a diagnostic section into your, OpenClaw JSON file. So this should be in the base level, so as a sibling of agents and commands. And then I have a few other things in here, like kind of troubleshooting that you can look at in the guide. But generally speaking, that should be all of the performance optimizations you need to now save a massive amount of money. Now, all of this is great. However, you don't know if any of this is working unless you run what's referred to as a token audit, where you actually look through and see how many tokens you're spending and on what. So let me set up a quick demo so I can show you an example of a token audit. Okay, so I'm just asking the agent to generate a bunch of text so I can kind of start spending some tokens and show you how it works. But notice if you go to the usage tab inside of your OpenClaw gateway here, you will be able to, it does take a second usually to load, see all of the usage that you've had in different sessions. So I think I need to filter, so I'm just going to press on today. And if I do that, let's make this a little bit larger, and you can see the number of messages we sent, the tool calls, the errors, the average tokens per message, the average cost per message, in this case 2 cents per message, the throughput, the error rate, the cache hit rate, all of this kind of stuff. So you can see right now already we're at a 99.9% cache hit rate, right? Which is very good. And then it shows us how much we're spending by the different token types. We have cache writes, cache reads, and then the total amount of output. Now, in terms of seeing the exact cost, it's always going to be easier if you do that directly from the, the provider. But you can see that it says we've spent 51 cents on Anthropic, right? And we had 41 cents on Opus 4.6, 10 cents on Haiku 4.5, and you get the idea, okay? So you can switch between this, see all of the usage, which is very good. However, there's actually even better ways to do this. Now, I just got it to do a bunch of stuff here, but what we can do is we can type /, and then there's a bunch of commands that we can run. Now, the first command that we can run is /status. When we do that, it will actually give us a status message, which tells us what model it's currently using, how big the context window is, the number of compactions, the runtime, and we can see what's going on in the current session. So that's the /status command. Now, there's another command that you should be aware of, which is /context and then list. Now, what this is going to do is give you a list of all of the different characters and tokens that are being used by various different files and what's actually included in the context that's being sent to your LLM provider when you're sending messages. So you can see in Workspace, we have this Bootstrap file, this Bootstrap Max, this Sandbox file, whatever, and we have agent, soul, tools, identity, user, heartbeat, Bootstrap memory. All of these files here have a different amount of tokens. You can see it estimates the amount of tokens here, and these are being injected into all of the prompts that you're sending to your LLM provider. Now, it also has a skill list, right? It has all the skills, a tool list, tool schema, tool reads, right? And then it shows you the total session tokens, which is 35,786. And the max context window is 200,000. And then you can see that it shows you this. And again, as I said, you can type /status and it will show you the current tokens in, tokens out, the current cache hit rate, the context window, all of that kind of stuff. And if you want a detailed, more broken down list, you can type /context and then detail. And this will give you something that's a little bit more detailed in terms of literally everything with all of the tokens if you really wanted to fine tune it. But generally, just enabling the cache already is going to save you a bunch of money. Now, what you can also do, and I'm just pulling this from another guide that I'm not giving away for free right now, but that I'll release later. And this is essentially a token audit prompt that says, please give me a token usage and cost audit for this session and recent sessions, include current session summary, per response breakdown, cost drivers, historical session summary, and recommendations. So you can effectively just tell it, hey, go run all of this stuff and give me, a detailed breakdown on everything that's going on with my actual cost and API usage. And if you paste that in and hit enter, it will do that for you, and you will be able to actually see, okay, am I spending a lot of money? How much is the usage? All of that kind of stuff. But generally, already at this point, you should see a massive amount of reduction in cost purely because of the cache and also the model, kind of switching, where you're not relying on, these super heavy models. Now, let's just quickly have a look at what it says here, right? So it says total token inputs, 38,000, total output tokens, 56, context usage, cache performance, estimated cost. And anyways, you get the idea. You can run this and you can kind of see how you can modify, what it is that you're doing, how much it's costing, etc. Now, even if you want, you can also just go and per API key, you can view in, for example, Claude, OpenAI, all of the different usage. You can see we used $1.30. Now that's a lot because we didn't have all of these things implemented, and you'll notice almost all of the usage is from Opus, which I switched over to and just didn't switch back from. So just make sure you have the correct default model and that you only use these super heavy models when you actually need them, right? Which is the whole point of having that, model routing implemented. Now, of course, there is more that you can do, but generally speaking, you should see a massive cost reduction by implementing these tools. Again, the guide is available from the link in the description. And with that said, guys, I think I'm going to wrap up the video here. Again, one of the best ways to spin up and use OpenClaw is Hostinger. That's what I used for this video. You can see how easy it was to get up and running. If you guys want to get this up and running or have multiple OpenClaw bots, then check it out from the link in the description and use my code TECHWithTim. I hope you guys enjoyed, and I look forward to seeing you in another video.